Welcome to Lecture 4 on the application of properties of determinant by Professor E.O. Efang. In this lecture, we shall see how properties of determinant will help us in evaluating and simplifying determinant very fast. Example 1. Evaluate this determinant and express your answer as product of linear factors. Solution. The fastest way of evaluating this determinant is to perform column operations on the determinant. The operation that will transform this element to 0 and this element to 0. And the appropriate operations are as follows. Column 2 is now transformed to column 2 minus column 1. And column 3 is transformed to column 3 minus column 1. This is column 1, this is column 2, and this is column 3. When we perform these two operations on this determinant, the determinant will become this. We can then evaluate this determinant by using row 1. Deleting row 1 and column 1. The determinant is therefore b minus a times c squared minus a squared minus c minus a times b squared minus a squared, then times 1. So this will give us this. b minus a into c squared minus a squared minus c minus a into b squared minus a squared. The expression in this bracket is difference of two squares, which can be factored into c minus a times c plus a. This is also difference of two squares, and we can factor this into b minus a times b plus a. So the expression will now become this. b minus a into c minus a into c plus a minus c minus a into b minus a into b plus a. Observe that b minus a, c minus a are common factors. So if we factor this out, the expression for the determinant will become this. b minus a, c minus a are factored out, and what we have left here is c plus a minus b plus a. Opening this bracket will become minus b minus a. A minus a will cancel out, giving us c minus b inside the bracket here. So therefore the expression for our determinant is b minus a into c minus a into c minus b. And this is the product of linear factors as required. Example 2. Let us also evaluate this determinant and express the answer as product of linear factors. Solution. Following the same procedure as in example 1, we perform these two operations. Column 2 will now become column 2 minus column 1. Column 3 will also become column 3 minus column 1. These two operations will then transform the determinant to this. We can then evaluate the determinant by row 1. So if we delete row 1 and column 1, the determinant will therefore be a squared minus a times b cubed minus b minus a cubed minus a times b squared minus b, then times 1. So this will give us this. A squared minus a into b cubed minus b minus b squared minus b into a cubed minus a. Notice that in this bracket there's a common factor a. Here there's a common factor b. Here there's a common factor b. And here there's a common factor a. So bringing out the common factors, This will give us AB into A minus 1 into B squared minus 1 minus here AB into B minus 1 into A squared minus 1. Now this expression is difference of two squares, and this can be factored as B minus 1 times B plus 1. This is also difference of two squares, which can also be factored into A minus 1 times A plus 1. So therefore, the expression will become AB into A minus 1, B minus 1 times B plus 1 minus AB into B minus 1 into A minus 1 into A plus 1. These are common factors. Bringing out the common factors, we'll have AB into A minus 1 into B minus 1, then into what is left here is B plus 1 minus what is left here is in bracket A plus 1. When you open this bracket, this will become minus A minus 1. 1 minus 1 will cancel out, leaving B minus A. So therefore, the expression for our determinant is AB into A minus 1 into B minus 1 into B minus A, which is the product of linear factors as required. Example 3. Let us evaluate this determinant and express our answer as product of linear factors. Solution. Again, we perform these two operations. Column 2 is transformed to column 2 minus column 1. Column 3 is transformed to column 3 minus column 1. These two operations will then transform the determinant to this. At this point, let us now perform row operations on this determinant. Notice that if we add row 2 to row 1, what you have here will be 0, and what you have here will be 0. So we now transform row 1 to row 1 plus row 2. When we do that, the determinant will become this. We can then evaluate this determinant by row 1. That's deleting row 1 and column 1. The determinant will therefore be A minus B times AB minus BC minus A minus C times CA minus BC, then times A plus B plus C. So this will give us the expression for the determinant A plus B plus C into A minus B into AB minus BC minus A minus C into CA minus BC. Then in this bracket, observe that there's a common factor B, and here observe that there's a common factor C. So if we bring out B here and bring out C here, the expression for the determinant will become this: A plus B plus C into A minus B into A minus C minus A minus C times C into A minus B. We have common factors here. A minus B is common. We also have A minus C is common. So if we bring out the common factors, we will have A plus B plus C into A minus B, A minus C. When we bring that out, what is left here is B, and what is left here is C. So into B minus C. This is now the product of linear factors that was required. Example 4. Evaluate this determinant and express your answer as product of linear factors. Solution. Let us set x equal to a plus 1 and y equals to a plus 2. which is equal to x plus 1. Then the determinant will become this. This determinant will therefore be equal to this determinant. By the properties that says that if a row of a matrix is multiplied by a number, then the determinant is also multiplied by that number. Equivalently, we can bring out a common factor from a row or column. So in this row, let us factor out 4. When we do that, the determinant will become this. Four times the determinant of 1 x over 4 x over 4. Then row 2 and row 3 remains unchanged. Let us now perform row operations on this determinant that will transform this place to 0 and this place to 0. That is, we perform the operation. Row 2 is now transformed to row 2 minus x row 1. And row 3 is transformed to row 3 minus x row 1. That's if we multiply row 1 by x and then subtract from row 2, this place becomes 0. Also, if we multiply row 1 by x and then subtract from row 3, this place becomes 0. So performing these two operations on this determinant, the determinant will now become 4 times the determinant of 1 0 0, then this column and this column. We can then expand this determinant by column 1. That is, we delete row 1 and then column 1. So that the determinant will therefore be y squared minus x squared over 4 times y squared minus x squared over 4 minus 1 minus x squared over 4 times 1 minus x squared over 4. Then times the 1 here. So therefore, this determinant is equal to 4 into y squared minus x squared over 4 all squared minus, in bracket, 1 minus x squared over 4 all squared. The expression you have inside this square bracket is difference of two squares, which can be factored as 4 times into y squared minus x squared over 4 minus 1 plus x squared over 4 times y squared minus x squared over 4 plus 1 minus x squared over 4. Observe that minus x squared over 4 plus x squared over 4 will cancel out. And minus x squared over 4 minus x squared over 4 will become x squared over 2. So therefore, this expression will become this: 4 into y squared minus 1 into y squared minus x squared over 2 plus 1. But y squared minus 1 is difference of two squares, and this can be factored as 4 into y minus 1 times y plus 1 into, let us replace y with x plus 1. We recall that y was equal to x plus 1. So that will become x plus 1 squared minus x squared over 2 plus 1. At this point, we will expand this. X plus 1 all squared will become x squared plus 2x plus 1. Then x squared minus x squared over 2 will give us x squared over 2, then plus 2x plus 2. That's this 1 plus 1 will become 2. The expression for our determinant will therefore become this: 4 into y minus 1 y plus 1 into x squared over 2 plus 2x plus 2. If we bring out 1 all over 2, that 1 over 2 will multiply this 4 to give us 2. The expression will then become this: 2 into y minus 1 into y plus 1 into x squared plus 4x plus 4. We recall that y is equal to a plus 2. So if you substitute a plus 2 in place of y here, that will become a plus 2 minus 1, which is equal to a plus 1. If you put a plus 2 here, that will become a plus 2 plus 1, and that will become a plus 3. And we can factor this one as x plus 2 all squared. So therefore this expression will become this: 2 into a plus 1 into a plus 3 into x plus 2 all squared. But recall that x is equal to a plus 1. So putting a plus 1 here, that will become a plus 1 plus 2, which is a plus 3, then raised to power 2. So the expression will then become this: 2 into a plus 1 into a plus 3 into a plus 3 squared. A plus 3 times a plus 3 will give us a plus 3 to power 3. So we therefore have the expression for our determinant to be 2 into a plus 1 into a plus 3 all raised to power 3. This is the product of linear factors as required. Example 5. Given that this determinant, in which the first row consists of the element x, y, z, the second row a, b, c, and the third row 1, 2, 3 is equal to 5. Find this determinant. Please note, for us to be able to evaluate this determinant, we have to express it in terms of this other determinant. If we can express the determinant in terms of this, then we are done. Let's see how it goes. Solution. Let us interchange row 1 and row 2 of that determinant. Recall that interchanging adjacent rows of the determinant only changes the sign of the determinant. So if we interchange row 1 and row 2, our determinant will become this. This row will now become row 1, while this one will now become row 2, and the sign of the determinant will change to minus. Next, let us interchange row 2 and row 3. And if you do that, the sign of the determinant will also change. That is, this minus sign will now become plus. So the determinant will become this. You see, row 3 is now row 2, and row 2 is now row 3. At this point, since in row 1 the elements are sums of two numbers, we can split this determinant into sum of two determinants, in which in one of the determinant the element in the first row will be x, y, z, and in the second determinant the element will be -4, -8, and -12. So this determinant will then become this. Now let us look at the second determinant. Let us look at row 1 and row 3. Observe that row 1 and row 3 are proportional. That is, row 1 is equal to -4 times row 3. That's if you multiply row 3 by -4, that will give us row 1, meaning that these two rows are proportional. And by one of the properties of our determinant, which says if two rows of the determinant are proportional, then the determinant is 0. So therefore the determinant of this metric is 0, which will then reduce this expression to only this determinant. Now in this row there is a common factor, which is 3. By one of the properties of our determinant also, we can factor out the common factor of 3 in row 2, so that this determinant will now become 3 times the determinant of x, y, z, a, b, c, 1, 2, 3. But this determinant was given to be 5. So therefore Our determinant is 3 times 5, which is equal to 15. Example 6. Evaluate the fourth order determinant as fast as possible. Solution. Evaluating this determinant by using cofactor method will be cumbersome and time consuming. The fastest way of evaluating the determinant is for us to apply either row or column operations to transform some of the elements to 0, thereby reducing the fourth order determinant to a third order determinant that can easily be evaluated either by using triangle rule or Sarus rule. Let us see how it goes. Let us transform row 2 to row 2 minus 3 row 4 and row 3 to row 3 minus 7 row 4. Here is the given determinant. I notice that since I have 1 here, I can easily use it to transform this element to 0 and this element to 0. That if I multiply this one by minus 3 and then add to this, I'll have 0 here. And if I multiply this one by minus 7 and add to this, I'll have 0. So therefore, performing these two operations on this determinant will give us this. We can therefore evaluate the determinant using column 1. So if we delete column 1 and row 4, the determinant will therefore become this. Note that the sign of the cofactor is minus, since we are raising minus 1 raised to the power 1 plus 4, which is odd. This is a third order determinant, which we can therefore evaluate either by using triangle rule or Sarus rule. Applying triangle rule, we have minus into 2 times minus 17 times minus 21. That will give us 714. Minus 1 times minus 5 times minus 20. That is minus 100. Minus 15 times minus 35 times 5 will give us plus 2625. Then minus, you then use this other diagonal, 5 times minus 17 times minus 20, that will give us 1700. Minus 1 times minus 15 times minus 21, that will give us minus 315. Then minus 5 times minus 35 times 2, that will give us plus 350. And this is equal to minus into 3239 minus 1735. And that is minus 1504. Thank you for watching, and keep on watching.